There are three tests that I like to call observational tests. Ones that you can just look at and decide whether or not the series will converge or diverge. The nth term test, which we discussed earlier, tells us whether the series diverges or whether we need further investigation to determine if it converges or diverges. So we looked at that one. The geometric series test deals with infinite geometric series. And from a previous course, you should know whether these converge or diverge. In short, it will converge if the common ratio is less than 1, and it will diverge if the common ratio is greater than or equal to 1. And if it converges to S, which is A1, the first term, over 1 minus the common ratio. For the p-series test, that works just like a p-integral. If you watched the unit before this, you should have become familiar with the p-integral terminology. Now we look at something called a p-series, 1 over n to the p. Now this works just like a p-integral. It will converge if p is greater than 1, and it will diverge if p is less than or equal to 1. We are now going to look at several examples from the notes packet, A through F. In each one of these, by observation, we should be able to tell whether the series converges, diverges. In some cases, maybe we will only determine that further investigation is required. Example A. The series from n equals 1 to infinity 2 times the quantity 0.1 to the n minus 1. And this is written in the standard geometric format. Let's write the first couple terms of the series. So it's going to be 2 plus 0.2 plus 0.02 plus ... The nth term is going to be a little bit redundant, but it looks like that. Now this is going to equal some number. It's going to converge to some number. So this is going to converge, and I can tell by observation that this is going to converge. Why? Well, we would say it's geometric with A1, the first term being 2, and the common ratio being 0.1, which is less than 1. So this is going to converge to first term over 1 minus common ratio, and so that's going to equal 20/9. It's going to converge to 20/9, and we could tell that by observation. Example B, the sum from 1 to infinity, 1/2 times quantity, 5/2 to the n minus 1. So by observation, I know that this is going to diverge. The reason, it's geometric with, now we don't need to state the first term, but I'm just going to do it so I get used to it. And the common ratio is 5/2. That common ratio is greater than 1, which is the reason it diverges. In other words, the sum will grow without bound. Let's take a look at C. Sum from 1 to infinity n over 2n plus 1. Can you observe and see right away what the series will do? Hopefully, you will say that this diverges. Why? Well, it fails the nth term test. If I take the limit as n goes to infinity of n over 2n plus 1, that goes to 1/2, which is not equal to 0, fails the nth term test, diverges. 1/2, which means in the end it's going to add 1/2 plus another half plus a half plus a half. If you keep adding a half, the sum is going to get bigger and bigger and bigger without bound. Example D, the sum from 1 to infinity, 1 over n to the 1/2. Observationally, we can see that this is going to diverge. Why? This is a p-series. So we say diverges as a p-series. Now p-series is a real term. unlike P integral that I used in an earlier unit, P series is defined. Diverges as a P series with P equals 1/2, and you remember that this is less than 1, or less than or equal to 1 really, and diverges. Example E, the sum from 1 to infinity, quantity 1 plus 1 over n, all to the power of n. What does this do by observation? Diverges. Why does it diverge? Well, I don't know if you see this, but the limit as n goes to infinity of 1 plus 1 over n to the n. What does that go to? That goes to e. The limit of the nth term goes to e. The nth term out there, way out to the right, is e. Doesn't mean that the series converges to e. It means the nth term converges to e. And we add e plus e plus e plus e plus e and keep adding e way out there. So this thing will diverge. The e is not equal to 0. It fails the nth term test. Example F, the sum from 1 to infinity, 1 over n squared, by observation converges as a P series with P equals 2, which is greater than 1.